So let's do some examples of factoring trinomials with a leading coefficient of 1. We'll start out slow and then we're going to get a few new ideas. The first one we see, our leading coefficient of 1 trinomial. So our first step, of course, is to just put down our double parentheses. Then we take the square root of x squared, which is x. And then, again, we're reading backwards starting from here. So the factors of 12 that add to 5. And when you think about that, we recognize that there are no factors of 12 that add to 5. And here's the first thing that I suggest people do, particularly when you get to things that have more than one or two sets of factors. We're just going to write out the sets of factors. So 1 times 12, 2 times 6, 3 times 4. And you'll notice that I go right in order. Whether it makes sense or not, I'm going to go right in order to make sure I don't miss any sets of factors. So I look at each of these and I see none of them will add to 5. So this one is prime or not factorable. The next one we have, again, we've got a leading coefficient of 1, trinomial, double parentheses. And again, remember that the parentheses are sitting right next to each other because we're implying multiplication here. The square root of r squared is r times r. There we go. And then the factors of 4 that subtract to 3. Those are our set of factors. So which one of those subtract to 3? So we put in the 4 and the 1. Again, the second sign tells us that the signs are different. And the first sign tells us that the bigger product gets the negative. So here we've got 4r. Here we've got 1r. So the bigger product is negative. They're supposed to be different. So we've got one negative and one positive. So this negative goes right here, and this positive goes right here. And remember, of course, as you do these, I'm not going to do all the foiling back to check, but I really highly recommend you guys do that when you're working these. I'm not going to do it because I just think it's kind of going to make the video go way too long. So do that on your own. And remember, when you do the FOIL back, you're just going to get your original polynomial. So let's look at our third problem I've got down here. Now this one is a little bit different. This one has something new. But again, we've got a trinomial with a leading coefficient of 1. So we know that b is going to be there. B times b is the only way to get b squared. Then what this one has is another variable. And you'll notice that the variable is squared on the end. And to take care of that, we're just going to do that right away and put that a in there. Once we've done that, all we have to do is do it exactly the same way that we did the last one. So we look at it and we say, what are the factors of 4 that subtract to 3? And you'll notice that I basically used the same problem because I didn't want to have to think too hard. I wanted you guys to just flow with the new variable there. So the factors of 4 that subtract to 3 are 4 and 1. You'll notice I put them in a different place just because I really want to emphasize it doesn't matter where we're putting these as long as we do those signs last. So we see that we've got that negative here, which tells us the signs are different. And this tells us the bigger one gets the negative, the bigger product. So this is 1ab. This is 4ab. So the bigger one gets the negative. The signs are different. So there's my positive and there's my negative. Okay, so here's another new thought. And that is, remember, we have to go back to our GCF idea. And this is a GCF we haven't dealt with yet with these. It is a variable GCF. So we see that there is a variable in each one. There's also a 2 in each one. So we pull that 2 out. When we divide that out, we're left with p squared plus 3p minus 4. Now, what we now see is we have a leading coefficient of 1. So we're just going to go back. So even though it started out with a coefficient, sometimes when we take out a greatest common factor, we end up with something that's a little bit easier. So we're going to go back to that idea of P and P, because we have a P times P is P squared, excuse me. And then again, factors of 4 that subtract to 3. So that's 4 and 1. The signs have to be different. That's what that negative there says. Let's point that out. So that negative says the signs have to be different. And then this positive says the bigger product gets the positive. So that's a 4p here and 1p. Bigger product is positive, smaller is negative. So there's our plus, there's our minus. And now multiply everything back to make sure. Now this again, the next one here, is a case where we've got a couple different things. And the first thing that I want you to notice is that there's a negative out front. As soon as you see there's a negative out front, you are going to make an assumption that you're either going to have to rearrange it or you have to factor that negative out. We also happen to have a 10, greatest common factor here. So we pull that negative 10 out, and then we divide it out. And now we have to ask ourselves the same questions that we've been asked. Except as I look at this, I just realized that I made a little mistake there. And I don't know if anybody noticed it or not, but it was with the sign. Because remember, I'm dividing out a negative 10. So remember, when I divide out the negative, positive divided by negative is negative. And positive divided by negative is negative. So that fixes that up real nice. All right, so that looks much better to me. Now the next thing that we're going to do again is say negative 10. And I'm going to do my double paren again with the square root of the first term in the first position. And now I just ask myself those same questions. If you can get yourself to say these things, it makes it so much easier. So the factors of 10 that subtract to 3. Again, you'll notice that I'm reading backwards. So the factors of 10, we've got two sets of factors, 1 and 10 and 2 and 5. Which one of these sets of factors subtract to 3? That's the 5 and the 2. And we know that the second sign tells us that the signs are different. And the first tells us that the bigger product gets the negative. So this is 5x, and this is 2x. The bigger product is the 5, so that gets the negative, and then the positive, since they're different, has to go to the 2. So there's our negative, and there's our positive. Again, I want you to go ahead and remember to FOIL there. Now we've got another one down here. This one isn't particularly special, except my suggestion at this point is to pause the video and come back after you've done this one to see if you're doing okay. So you see it's a trinomial with a leading coefficient of 1, so we double down on the parentheses, and then the square root of the x squared is x, and then we've got this 36. Now I'm going to go ahead and do all the sets of factors. So it's 1 times 36, 2 times 18, 3 times 12, 4 times 9. 5 doesn't work. We've got 6 times 6. I want you to see this because you'll notice that I'm going right in order, and this is something that I do regularly. If I do not see the set of factors right away, I just write it out. It's quick, it's easy, and I don't want to think that hard, and it's much easier just to have it written down. So now I've got all my sets of factors. I'm looking for things that add to 13. Here's the set that adds to 13. So that's 9 and 4. The second sign is positive, so it tells us the signs are the same. And since it's positive, the first sign tells us what that sign is. So it's positive and positive. Remember, don't forget to go ahead and FOIL that just to verify. Again, I'm going to really suggest, again, pause, try these, and then come back after you've tried them. See, we've got a trinomial, leading coefficient of 1, And I know I keep rambling on about this stuff, but you have to keep saying these because one of the keys to doing factoring is recognizing what you're looking at. So trinomial leading coefficient of 1, let's just add that idea that we see that there's no GCF, and we also see that it's in good form, that we'll talk about that in another video. By good form, I mean it's in descending order. So we've got our double parentheses. The square root of x squared is x. Now we want the factors of 56 that add to 15. So again, I'm just going to go through here and start pulling factors. So 1 times 56, 2 times 28, we'll try 3, and 3 doesn't go in evenly, so we try 4, 4 works. There we go. 4 times 14. 5 doesn't go in because it doesn't end in 0 or 5. How about 6? So we try 6. If 3 didn't work, anything that has a factor of 3 won't work, so 6 won't work. 7 works because 7 is a factor in 14. And hopefully we know that 56 is 7 times 8. So we get back to 8, and once we see that these numbers are right next to each other, we know that we've pulled every single possible factor or set of factors that we can. Now we're looking for factors that add to 56, and we see that that is, that add to 15, so we see that that's 7 and 8. Signs are the same, so that means both of these are going to be exactly the same sign. The first sign always tells us what that sign is. So they're negative, negative. Again, multiply it back to check it out. Our next example are double parentheses with the x in the front. Now, what are the factors of 27 that subtract to 6? Some people see these right away. Some need to do this at least part of the time. Some want to do this all the time. I don't care. Just find a method that works for you. Now, we know 9 times 3 and 9 minus 3 is 6, and 9 times 3 is 27. Factors are, the signs are different. Bigger product is negative, and there we go. Now let's do this last one on this page. Again, trinomial leading coefficient of 1. We've got an x and an x. And now we've got 108, and this is where things can really get dicey because it's a big number. So I really highly recommend that you start making your list. So it's 1 times 108, 2 times 54, and then we have to keep going. So we're going to see if 3 works. So 3 times 36. 4 works because there's a 2 here and 54 is even, so we can tell that that's going to work. Remember, you can pull out your calculator for these. It's not that big a deal. I really recommend doing this, though, to make sure that you don't miss anything. 5 doesn't work. 6 works because we've got a factor of 2 here and a factor of 3 here, so 6 is going to work. We can, check ourselves as we go. The more comfortable we are with the numbers, the easier this is. So 6 times 18. Can we tell if 7 works? You're probably going to have to just do the division or use the calculator, but 7 does not work. 8, does 8 work? 8 does not work. Does 9 work? And the answer to that is yes, it does. Does 10 work? No, because the 108 doesn't end in 0. 11, again, it's one of those ones that you would have to kind of do the math on and check. But 11 does not work. And then we're back to 12. So as soon as we meet back up, we know that we have gotten all the possible factors. Now we go back and we know we're looking for things that subtract to 3. Well, 9 and 12 subtract to 3, so there are our factors. And we know that the signs are different. Bigger product is positive, so that's going to be our bigger product, so that's positive, and that one has to be negative. And now you need to go out and just practice the heck out of this.